Welcome to the January community forum for Gen3. Uh, as usual, we try to kick off the year with a roadmap for the year, development roadmap for the year, so we can share with you what we think is going to be completed in the coming year, so you can plan accordingly, and also to get your feedback. Hopefully, there'll be a good discussion today. We'd love to hear from everyone. Feedback on what they hear and maybe feedback on what you don't hear, things that you think that we should be focused on that you don't see. So I think you all know me, but I'm Michael Fitzsimons, Director of Research Programs at CTDS. And shortly I will pass it on to Bob, but I just have a couple quick announcements. So next slide. So yeah, so like I said, welcome. Then we have one slide from a community member after this. We'll spend a couple minutes on that. Then we have a review of last year's roadmap. How did we do? Then we'll talk about the 2026 roadmap, and then the steering committee will organize a discussion with everyone to get your feedback. So one more slide, Faye. Okay, so I'm going to hand this over to Luca from the Data for Common Good. He and team have, so the idea here is that they've talked to us about this feedback. It's not a topic that we've been immediately, able to address. And so we wanted to give him the podium to like talk to the community a little bit, maybe find some like-minded individuals that may be encountering a similar hurdle, see if we can make a connection either on a process or maybe on a code update as well. In general, we encourage folks to we like to give folks a couple minutes at the beginning if they have any particular topic, but this topic is brought to us from Luca. Luca, are you here? I haven't looked yet.
Yep, I'm here. Thank you, Michael.
Okay, please go ahead.
Yeah, I just tossed here a couple of number for reference, but one of the problem we face is the time to load data inside the Gen3 platform, and specifically I refer to um, the Postgres database or through Sheepdog. And so in our example, we have a small dataset, meaning it's 46,000 subject. We have a good amount of like nested nodes with a good amount of attributes. As you can see, overall, it's like almost 2 million records across the different nodes. But to load this amount of data, it takes usually 3 to 4 days, which is like about 8 to 10 record per second, which is pretty slow, since um, I would expect like with parallelization and such to get a little bit faster in this. Uh, I I approximate 8 to 10 seconds per record, sorry, 8 to 10 record per second, and I can be too precise because of course the time depends from the size of the record. So if there are like 10 attributes or 50 attributes for that particular node. Um, and yeah, I'm looking for other people that may be interested in collaborating, finding a way to improve these. And two of the main problem I can think of that cause this slowness are, well, the actual graph implementation with sheep doing. We already talked in the past about potentially doing Neo4j or other approaches, and the related transaction system to like load data. And that is one problem. And the other problem is more on the DevOps side, that the the auto scaling doesn't really work for sheepdogs. So like when I know we're doing a data load, I usually just go in and increase the number of sheepdog pods manually for that time being. So that would be another thing that would be nice to like work together to um find a way to make it a little bit more automated. And yeah, I think this is it for me. Thank you, Michael.
Just a clarifying question. I'm not sure it doesn't always seem to be this slow. I know you do a lot of nesting. Presumably, the depth of the nesting is part of the reason. Luca, could you just talk a little bit about the average nesting, or is that unrelated to what's going on?
I think it's unrelated because we load by node, so we don't like their relationship is usually just like one level up to like the parent. But yeah, our dictionary is more or less on three level, well, I guess four. We have like a person, which is the actual like identifiers for like real people. Then there are subject that is like the role that that person has on a trial, on a study in general. And then we have a bunch of nodes underneath subject that relate to the like various different like attributes and characteristics. Uh, some of those, like tumor assessment node, as is pretty large, meaning there are, I think, 60-ish column. So that is usually the slowest one among these. Um, but yeah, I don't think it's related much to nesting, but more with how like the transaction system works here and with the fact that it doesn't scale up much. Like if there were like 10 ship to instances, I'm sure it will be way faster. But since I'm change it manually, I usually set two or three instances versus being able to like scale up to like 10 for like, I don't know, an hour, sure, whatever it would take to load, and then scale down to one.
Thank you.
Um, okay, well, yeah, thanks, Luca. Like I said at the beginning, this is we have talked a little bit about it, but we don't want to impede, what the community can maybe, work together on this. But please keep us in the loop if you, as you, if you get some discussions going. We're, happy to support that. Um, okay. All right. So with that, we're going to kick off a review of how we did last year. So we've put together basically a list of the roadmap items that we talked about doing, and then we'll just kind of review what we've accomplished. So next slide, Faye. Um, so Bob, I was assuming that you were mostly going to speak to this, unless you need any help with this slide or the next one.
No, I'll take it from here. I just want to remind people of the process that we get to the roadmap. So there's sort of an initial draft of the roadmap from the University of Chicago CTDS team. Um, there are a couple discussions of that roadmap with the Gen3 Community Forum Steering Committee. That's phase two. On that basis, there's a presentation here. Then phase three is a discussion with the community forum after the presentation. That's part of this meeting. So it's a three-phase process. And as we just heard from Luca, we want to hear about pain points. So if data loading is a pain point, we can prioritize that. This is a scorecard from last year's roadmap presented a year ago. Um, After a significant amount of work by the team, the front-end framework is mostly complete. It's certainly complete enough for most projects, and there'll be a launch later in January or February. We're in the middle of a soft launch now of a pretty complex Gen3 Commons that uses the front-end framework extremely extensively with a lot of custom tools. Um, the We've also wanted to make the GA4GH task execution service TES a service fully integrated into Gen3. That's mostly complete in terms of capabilities. And then There's going to be some there's going to be further testing and with a target of general release next quarter. The improved documentation has been complete for some time. We're going to talk a little more about front end improvements on slide 11. That's mostly complete. So the ability to more easily build Gen 3 meshes by specifying by each node that wants to join a mesh, creating a mesh card, and then having the data hub, the Gen 3 data hub, automatically create the mesh. We have a prototype of that. It's partially complete. We'll talk a little bit about that. For those groups building meshes, it's certainly enough to get started using. The Common Service Operations Center, we have multiple implementations of that by different parties, the Australian Biocommons, the OCC, the University of Chicago, and others. I guess I'd call those prototypes, but some of those groups are using these actively now. The integrated AI capabilities has started. We have some of those partially integrated and being hardened. Others will be added. So I would say, I think we'll talk a little bit about the embedding service today, but this is I would think of this as a 2-year project, and we're 1 year into it. So we have a good understanding, I think. Well, we've thoroughly explored a number of case studies and have used that to create the first version of AI Commons, but we have not rolled out AI meshes yet. We have meshes, but not AI meshes. So yeah, I would call this our secure research environments. I think that's a more accurate description. And some of these controls are being added now. And depending upon your use case for a secure research environment, the Gen 3 implementation should meet that. So, for example, if for some European uses of secure research environments, that's what we're targeting. For a complete clean room or airlock, that's not what we're targeting. So, but we'll be having a version of secure research environments that will be slowly hardened and come out in the next quarter or so. We didn't have yeah.
Sorry to interrupt. Just in case it wasn't clear from this slide, these slide items were suggested by the community last year. They weren't on the roadmap that was volunteered, but we did want to give an update on progress that we might have made with community items.
Yeah, I was confused. So we have made progress on secure research environments, but did not tackle airlocks. Okay, thank you, Michael. And we did not make progress on, as indicated here, Gen 3 in a box or native graph database. Or on the other hand, the schema variation was completed by the community, and that's an important capability. And I hope the community continues to contribute various things to make it a little easier to update, manage schemas, and push them out. Okay. So we've added some. Well, we're going to talk about the front-end framework and analysis tooling, but yeah, we've also talked a little bit. One of the things we're doing for the AI Commons is making it easier to add components to Gen 3 to support that as part of the front-end framework analysis tool framework. And in particular, you have to go to another project page outside of Gen 3 but we've added a few of these tools, and we've started to add tools using the model context protocol. And one of these is for building cohorts with natural language. And so we made some progress with that. It's complete. Next slide. All right, this is the roadmap per se. And again, I want to emphasize that we're looking for your feedback to finalize this. So we'll go over this in a few slides, but DERS has continued to do new versions of their standard. And so we'll be adding that. We'll be working on that. We'll be adding some ability to make PFBs, portable format for biomedical data, adding those capabilities, including the ability to search. We'll be adding improvements to the front-end framework. We'll be making the workspaces a little easier to use, and also supporting making it much easier to put standard installations of software in all the workspaces as they launch, a little bit like when you have HPC environments, they come with standard installation of software. So each workspace doesn't have to install software, but it could be done across everything. We have a good front end for cohort discovery in the new front end framework, but it needs some back end services to be complete. So we could have cohort discovery and cell level access. That will be added. We'll be, as you'll see, adding improvements to the mesh. This CSOC for all the different implementations by the different groups is a work in progress. And in particular, the U Chicago team is going to create a CSOC dashboard. We will be adding we have a prototype file server in Gen3, and we'll be hardening that and making that generally released. As I mentioned, we're starting year 2 of a 2-year capability for a 2-year addition of AI, a 2-year project to add AI to Gen3. We have a slide on that, but we'll be adding specific services, including, well, we have an embedding service. We'll be adding a model repository service, and we'll be improving our integration of an inference engine. We're going to be adding the ability to interoperate with the data access committee into the for Gen3, and we're looking, depending upon our resources, to do additional things. Next slide. We're going to go over these in detail now. So I'm not intimately involved in this, but Gen3 more or less supports DRS 1.2. And so the idea is to upgrade that to follow DRS 1.5. That involves bulk retrieval and some of the additional things listed there. And if there are specific questions, I think I saw Kyle Elrod on the phone. And we also have, I think, Michael Lukowski on the phone who can go into this. Next slide. So right now, PFB is PFB is designed to support the graph data model. That's the most common data model in Gen3. But the idea of PFB and the tooling for PFB and its use within the Gen3 system is really what I call the meta schema. That is independent of whether it's it should be the idea of the core concept of PFB is independent of whether it's a PFB based on Avro for a graph model, a fire model, an OMOP model, et cetera. So one of the in the US, there's been an important standardization on fire, and so the idea is to make changes to PFB to support fire natively. And we'll also do other things such as dealing with nested PFBs so we could support more complex data sets. Next slide. This is the first we're beginning the first full production releases of very complex Gen 3.2 platforms developed with the front-end framework. The front-end framework is sort of what separates us from 3.1. The new front-end framework is 3.2. So there'll be a number of changes, including tools for developers for faster hot reloads and configure validation, et cetera. We'll also support more support for fire and various other things. That's if you have, hopefully, we've been using parts of Gen 3.2 for a year now. All the a very rich supply of tools was developed in October, November, December, January. So it's in terms of the actual tools available, there are a lot more tools available. If you have specific challenges using 3.2 that preclude you from using it in your project, let us know. We really want to make 3.2 the default engine, the default front end in this calendar year in 2026. So if there are things that you need, we really want to hear that so you have no problems using 3.2. Next slide. So I talked a little bit about this. This is the idea that it will be easy to create. You'll have tooling based on some standard open source tooling. You'll have tooling to create rich combinations of software that will launch in each workspace. And it will make it easier to handle multiple versions and different images, et cetera. And so there'll be, in most cases, we hope that if this is done right for your users, once they launch a Gen 3 workspace, will not have to install very much. And that also, if you have to isolate your Gen 3 workspaces from the internet because of your security model, it really makes it much easier when all the software comes pre-installed. So that capability is being developed right now. Next slide. So as part of this, we're going to be for some of our projects, we lock down the workspaces so they can't really interact with the so they really can't be used for exfilling data. And so that's part of the secure research environments or trusted execution environments. And so that's coming. And we also want our workspaces to interact with you can run WES in there now, but we want to run WES using the new WES service that is coming out. So that will make the workspaces easier to use, and for some applications, just more locked down if your particular security requires it. Next slide. So we had hoped this would come out in 2025. We got the front end for cohort discovery done in 2025, but as I mentioned, we need to create a more granular or more fine-grained access data, basically data access support in the back end. And so I know a number of people around the world need this cohort discovery. So this is a priority. We just have to do a little more back end support to support the cohort discovery in the front end. Next slide. So this is in part a GA4GH activity. It's one of the outcomes of our accelerating research with data meshes and data fabrics series of conferences. But if you create the right JSON node card, then if you want to bring up a mesh from 10 nodes, if each of those nodes has a node card, that could be mostly automated, except for some of the OIDC Connect configurations. So this is a significant step forward. We have prototypes of this working, and this will be rolled out, and the paper will be done in 2026, and we'll be working to make this a GA4GH standard with the community. Conversely, if there is a mesh, a node that's not part of that mesh can read the mesh card to make it very easy for that node that's not in the mesh to join the mesh. So it works both ways. I just have to get some water. I'm losing my voice. This is very much a community process. So if you want to get involved, please do so. Today's meshes work by, we launch a hub, and that hub pulls metadata from all the nodes in the mesh. We have 4 production meshes right now. That's how they all work. As we grow the number of meshes and as the number of nodes in the mesh increases, that's really not as scalable as it should be. So we've prototyped and we'll be moving into production an alternate way for each node in the mesh to share its metadata with the hub. So any queries from the hub can see all the data in the mesh or all the data sets in the mesh, depending upon the use case. And so we're using a pub sub mechanism for sharing metadata between nodes in the mesh with the metadata they're sharing and the hub in the mesh. And that should be a significant improvement. Next slide. The original vision for the Common Service Operations Center was you would have one pane of glass, and you could not only launch different commons, but you could monitor them and manage them. And so the goal here is for the CTDS to develop a dashboard that not only I may be, this may be more aspirational than what we'll get, but the idea was that the dashboard would be not only valuable to what the U Chicago CSOC is doing, but ideally helpful to the other CSOC infrastructures being developed by other teams. But the idea is to have a dashboard so you can have a single pane of glass for each operator of Commons, of Gen3 Commons, to see to more easily manage multiple commons, monitor multiple commons, and change services in multiple commons from a single pane of glass so that one operator could very easily do multiple commons. And again, the idea is hopefully, when possible, if possible, to integrate with the other CSOC efforts out there. Next slide. I mentioned in the US the FHIR format, sort of EMR-based format is really important. So we have a proof of concept FHIR server, and we want to make that a production FHIR server. This is an important, right now they're Gen3 graph database, they're Gen3 servers that support graph data and support OMOP data, but none that support FHIR data. So the idea is to make this a native FHIR server in Gen3, and also to get a little closer to having multiple persistent engines in Gen3. But here we have a proof of concept and we want to productionalize it this year. Next slide. I've spent a lot of my time on this. We're running a workshop on this next week. We have a late technical paper describing how we're conceptualizing AI commons for Gen3. The idea, the basic idea of Gen3, just to remind you at 50,000 feet, is we've always supported fair data, and then we've always supported a data model that allows you to auto-generate the commons, long before fair became important. But to do that, we didn't think of a Gen3 data commons as software that was designed to support dozens and dozens of requirements, unlike some competing systems. But we try to figure out what are the smallest number of services that would support a functional data commons, the so-called end-to-end design principle. And that's the idea here. So there was quite a list of possible things we could add here. It's come down to an embedding service that is more or less done. We'll add a model repository service. So if you have 24 AI models, you can manage them. We'll be adding a standard ZLLM inferencing service. And that's about it. We can already build models from workspaces. We can already build models from our West, I forgot agentic. We'll also be adding agentic interfaces, MCP interfaces. We have those now. So it's the 4 core components. I'm doing this from memory after a long, long day, but our embedding services, model service, inferencing service, and agentic interfaces. What we're missing seemingly from the list is how do you build models, but we can do that from our workspaces. We could do that from our West services. So that's how we're thinking of it now. With these, you could add a lot of other things. Just with the Gen3 commons, you could add a lot of other things. But the idea is those are depending on each commons and not part of the core services. Next slide. This is more about that. And this also has a few other things. Federated learning, we're going to be prototyping in 2026. The idea is to do that with the NVIDIA Flare interface. We have the ability to support GPU on-prem. That will be rolled out into production. That's really important, just because it's so much more cost effective. I talked about embeddings. We're making different enhancements to embedding services. Next slide. I've talked about model inferences. Yeah, I've talked about all these. Next slide. Ah, um, the idea is that we've had a number of our comments that have integrated with specific systems run by different data access committees, but we haven't made this a core service. So based with basically different people from the community on the phone has seemed to settle on REMS, and so we'll be integrating REMS into Gen 3. Um, we try not to show emotions, but we like to support anything in the community. And if the community likes REMS, we like REMS. Next slide. Um, we have some people we trust um, moving to Star Rocks instead of Elasticsearch. Um, Elasticsearch is expensive, and so uh, this is not on our roadmap, but if we could maybe find a partner who wants to work with us integrating Star Rocks into Gen 3, that might be interesting. Um, we continue to support OMOP. Oops. Give me 1 second. Um, we've made some progress integrating Keycloak in a more unified fashion and know that's something important to the community. Once we do that, it should be a little easier to integrate Auth0 or some of the other ones. Um, we have people running OpenShift in production, and so we'll be giving more. I guess we may give more support for OpenShift because we have to support it in production. And I'm not tracking what we're doing with Celium, but I guess we're thinking about doing something with Celium. Next slide. So, as mentioned, we really, really want to open this up for discussion. Claire has volunteered to lead the discussion. I've committed to keeping my mouth shut, so I'm turning this over to Claire at this point.
Thank you, Bob. This has been awesome. I think it's the whole steering committee. I'm going to drag everyone in here. So I think we'll have sort of a little bit. I think we've got lots of time, nearly 45 minutes. So Bob, you've been very efficient. Thank you. Have a bit of a discussion, maybe as the steering committee in terms of kind of first impressions and favorite items and what's missing, and then open that to kind of questions. And I think actually Alan's already put a really good one in the chat that I also had about the front-end framework. So, Stephen, I know you need to leave at some point quite soon. So did you want to actually start off with any impressions or thoughts to give you that chance? We can't hear you if you are speaking. I don't know unless it's mine. Oh, audio issues. Maybe I'll just keep nattering on until you interrupt me, Stephen. So I think there's a few items that I'm really excited to see on the roadmap, and I think we're going to need to. Oh, here we go. Maybe.
Hi, is that better?
Perfect.
Thank you, Bob, and thanks everyone. That was awesome. I think it's really good to see that, particularly the community-driven activities coming along as well. And as I think that was something that we were kind of thinking of over the last couple of years to kind of give more prominence and give some more time and space to. I don't have anything specific to add. I think I think my main commentary is that it's really great to see the road mapping process happening. I think this is maybe the third year we've done this. So it's I think given it's happened a number of times now, it's a thing and it's got cadence and it's a kind of a feature or a part of the annual kind of planning process um and calendar of Gen 3 and the Gen 3 community, which is really, really great to see happening. So that's really all I have to add at this point. Otherwise, the actual roadmap itself and everything is absolutely of relevance and related to us here at the Biocommons. And yeah, really excited to see what's going to come through this year.
Thank you, Stephen.
Thank you. Kyle, did you have thoughts you wanted to share as well?
Well, of course, I'm very kind of interested in, I guess, the various aspects that touch to again the larger data science community. The different organizations. I think GA4JH was mentioned. I think and like in getting PFB out to a larger, um, broader audience, I think is also a good idea. I think the thing there was something in the way that you talked about PFB as well is that is like it's not specific to Gen 3. And it's very important to identify these touch points in these data systems where you've worked on something that's not necessarily specific to your own system. And how can we work as a larger community to make these things interoperable? So even if they're not fully invested in the Gen 3 ecosystem, there's parts of it they can pull out and utilize and reappropriate for other systems. But it makes I think the larger open science community all that much better. Again, if we can, and it is extra effort to design stuff that is interoperable. Because it's so much easier just to like build your own thing and not bother to make it compatible with anything else. But I think if put in the effort, I think it's much better for the open science community.
Yeah, I agree, and Kyle, and the nice thing about PFB is anyone who's worked in the space for a while has old data and they can't find the schema. They get disconnected. There are a couple candidates. They can't find the larger data sets that were supposed to be attached. So PFB incorporates the schema in there. Is based on average, so it's fast, has the data, and points to large data sets through DRS. So it's independent of Gen 3 and just precisely the way you mentioned. And through the community forum and through CTDS interest in supporting general open science, if there's specific things we could do, like make big or small changes to support other interoperability that you have for moving data across systems or archiving data or exporting data and putting it into a lake for lifecycle management. That's what we want to see in PFB. That's why it was designed.
Yeah, yes, I think that's very great. And again, I think there's other opportunities, especially going into the AI space. I think it's a really interesting field where there's a lot of innovation going on right now. And I think a lot of standards have been proposed, but not fully kind of like fleshed out, like separating what is a standard from like, oh, this is just, the technology that implemented it first and we're using it as a standard. Which is kind of sometimes a different idea. So especially like you mentioned, like the federated computing, I think there's some really interesting stuff there, but like how much of it is like NVFlare specific versus like, well, there are technically other federated computing platforms. I mean, are we just going to end up in this world of like federated computing like silos? How can we kind of start to bridge those gaps?
Awesome, thank you. And Dana, I think our newest member of the steering committee, did you have some commentary you wanted to add at this point? Am I mispronouncing? I think she's on the call.
Maybe she didn't know she was going to be called on. But Donna, are you there too?
No, I don't think so. Donna is here, Michael.
I see her on the list, but that's
Oh,
okay.
Okay, well, we'll check in again later. So I think in terms of yeah, the roadmap itself, likewise, I think it's looking really awesome, and there's a few bits that we're very keen on. The sort of the REMS integration, we're one of those groups who've done that and are keen to use it. And also that granular access. I think that sort of that cell-based data access will be brilliant. I had a few, and actually, I had the similar question to Alan in terms of the front end framework and who from the community so far has adopted it. It's on our to-do list, but we haven't. I must confess, haven't got there yet. But I'd be really keen, and I don't know that anyone answered that question, but if anyone could sort of raise hands if people have adopted it or um, sort of yet in terms of for prod instances of their Gen 3. I don't see any hands. I guess I'm curious, and maybe this is a question back to the Gen 3 team as well in terms of which groups you've worked with to adopt it, and do you kind of consider it, I guess, production ready, and should we be adopting it now? Or I think there were a few sort of 2.2 was on the roadmap. Um, should we be waiting for that?
I mean, we have one partner, but they're in a quiet mode now that has launched a production system in 3.2. We have multiple production systems in 3.2. Thank you, Stephen. So OCC will be launching all their commons in 3.2 when they bring out their CSOC. So they'll come up to C2 over time, 3.2 over time. Craig, can you flash just what, or can we show them what a 3.2 production commons looks like, or is that not something we could show for a while because of the soft launch?
I think Craig is
Is
on.
Craig there?
I don't think so.
Okay.
But I mean, we could share the.
Oh, that's good. The Omics 3 project. Yeah. I mean, 3.2 is definitely ready for production. There's no question about it. We support multiple 3.2 systems in production. Third parties have supported, OCC's is moving to it. So it's definitely ready for production, and it gives you so many more capabilities. I know everyone is research constrained, but I think it's a smart thing to move to because in the end, the more users you have, the happier you are, the more impact you have on the community. And 3.2 gives you a lot of tools the community can't get otherwise. I think so. From that viewpoint, I think that's the significance of 3.2.
I think
Yeah,
we do
that's
have
really
some.
awesome. Oh,
Oh, sorry, Claire.
no,
Just
you
I was
go.
gonna add that we do have some active threads with a couple community members, working to adopt the front end framework. And as Bob said, we, do value that feedback. I think there are still a few gaps, and so pointing that out to us is good to hear. And we're, working to try to close those this year. But
Awesome, thank you. Oh,
I think it is, as Bob said, you can start working on it. There are some pages. If it's not there, you can run the data portal within the front end framework. So if there's like one page missing, that's an option.
I wonder if and maybe we could lean on some of the groups that have already done this, and I'll put Josh under the in there since I know him, whether maybe a future community forum could be based around the sort of the learnings from adopting, or sort of a tips and tricks or something, in terms of building through that front end framework and adopting it.
Yeah, for sure. I think our original plan at the moment, we've got AC/DC running on the previous on Portal, and we've got our new project Omics 3 on 3.2. And our initial plan was to have a go at using 3.2 and see, what challenges and what kind of hurdles that we actually face with that one while it's still in its development stage, and then see if we can bring that over to AC, DC, and try to upgrade that one eventually. And I think we've actually identified a few sort of blockers which we've brought up with Sarah. So yeah, Bob, your team has been helping us kind of get through it. So I think these are all useful lessons to keep in mind, um, as we move through this experience.
Joshua, that's very, am I on mute? No, that's very important. I think in terms of the priorities that we have in Chicago, getting people into 3.2 and supporting AI are some of our higher priorities. So we really want to hear those. Are they still blockers, or are we still working them?
Yeah, we're still working on them.
Okay. I'll dig into that a bit. Thank you.
Cool. Thanks.
So I think before turning the conversation back to AI, because I suspect we can fill the time on that, I did want to just I guess highlight a call for other kind of community projects or working groups, or if there are features that people need that were not on the roadmap. I think now is a good time to sort of reach out, put it in the chat, and let us know. And even if it's not sort of a Gen3 team core priority, I think we can form working groups, and sort of we've had quite a successful one around the Keycloak integration, and I think as Stephen mentioned earlier, it's the last year, it sort of feels like the community has been working together quite a lot more, which is great. So feel free to put things in the chat or ideas, and we can reach out and coordinate. I'm keen, I guess, to get people's thoughts, and I think we can probably open to kind of open questions, but around sort of the AI integration, I think technically there's a lot on the roadmap already coming in, and we'll solve a lot of the technical aspects. I'm keen if people or to hear if groups are, I guess, from a sort of ethics and a responsible AI in the same sort of positioning as the technology, or whether there's still concerns or aspects that groups are working through in that space.
I'll just start by saying that we depending on funding outcomes this year, that might be an area of focus. We submitted a large proposal late last year in October, to extend our AI in life sciences work, including our Gen3 Commons aspects, and if so, that includes a lot of security and other considerations specific to I guess the intersection of AI and platforms like Gen3. So if all that goes well, we'll be doing a lot more in this area this year. So yeah.
Thank you, and hope that goes well. I'm just going to
Stephen,
call.
real quick, Stephen, are you using Flare or something else, or aren't you supporting distributed federated immediately?
Not at the moment, I don't think. No.
That makes sense. We pushed it further out in the roadmap because there's so much more that you need near term. Thank you, though.
Does anyone have any other thoughts? Kind of open to the floor on this one.
Well, I was gonna put a plug in at least for the GA4GH cloud AI ML work group, and it's kind of we're in the same boat where we're looking towards federated learning, but realizing there's a whole bunch of ancillary stuff built around it that really needs to be solved first. And even if we like sit down today and say, okay, we're going to use NV Flare, we're going to go, and it'd be like, no, there's batch effect, like just making sure the data is in the correct format in both sites. Like I'm curious as to how much just being able to provide provenance records for files and say, yes, this file right here was processed using this workflow would actually, is that the kind of stuff work that we need to do before we can actually call data really AI ready? Because then you at least know like, okay, it's processed in this way so that when my code hits it, it will work. Which is not like, again, when you look at like the way that a lot of the groups are working on federated work learning right now, they're working it from this angle of almost like the perfect spherical cow experiment, where it's like, no, that's not how the real life is. And no, the data is ugly and messy, and you have to kind of, and now you're expected to do batch correction when you can't even see the batches.
Yeah. Kyle, I think my thinking has changed along your lines. I see Flare as a good solution if there's one company with one software running on multiple devices where they control the data, and then you want a way if the data is on, say handhelds or laptop or
Hmm. Yeah, it's a solution for
edge
like Apple.
servers.
Yeah.
And yeah, and then Flare works really well. If you have multiple organizations with their own data wanting to build federated distributed models, there's so many more problems you get to, like you just described. And that's why we pushed it off for a while to focus on getting one single AI commons up with a good what the community needs in it for that reason. But um, Apple doing um, you know uh, pulling data, doing what they need to do in phones, and the data small, you could do the encryption. It really is an elegant solution. Or data, your own software on multiple systems in your own data centers, running your own software with your own data. Um, but that's not our first use case in this community, as far as I can tell.
Yeah, even if we talked about like, the NIH data sets or something like that, and just treated like, okay, if it was possible to do federated learning just on the data that is owned by the NIH, as one model. It's like, well, even then, you can't, there's batch
Can't do
effect,
it.
and that's a
Yeah.
singular organization. It's like, no, there is no singular NIH. There's a multitude of different projects. Yes, technically, they're all under the same umbrella and the same security, like DB Gap or something, but they're not equivalent. And that's the best case scenario. Then we talk about like, well, okay, if we like image AI, the dream would be is we could train a model that goes out to every hospital and trains on like images coming off of MRIs or something from every hospital in the country or something like that to build a real foundation model, have a data set that's larger than anybody could produce on their own. But yeah, the second that you start talking about doing that, it's like, well, yes, again, different machines, different batch effect, and then just the security protocols around that would be a nightmare. So, what are the things that can be done at small scale to help kind of at least, again, map the terrain, lay the groundwork?
Yeah. I mean, just talking about AI, if several of us were running, well, I mean, this is, I think, the same thing on the GA4, GH. We're running, start with the simplest case. Three of us are running um, Gen 3 AI Commons with AI capabilities um, over a particular cancer with a common model. Then it's relatively simple with Gen 3 today to scatter gather um, container-based workflows, and federate the results fairly straightforwardly. That would be an interesting case. Obviously, that's been done before, but to do it with AI Commons in calendar year 2026 is something we could do and would really inform what we're missing from the AI Commons and, how you want to build out the federated there. But there it's very simple. Data remains where it is. You have coordination and you use current resources to take a containerized workflow that can build the model or a containerized workflow that does inferencing. So you could, in what I just described, you could do that by shipping the model, keeping the data in the commons, and aggregating the results. That can all be done with the AI commons that will be ready in a quarter or so. Because those are the services we have. We have model repository service, inferencing services, and ability to West workflows or notebook workflows. So you could do all that. We also will be supporting embeddings for various reasons. So there are certain things you could do with embeddings also.
You mentioned embedding services actually. What are the different actions? I think you kind of a high level said we'd have an embedding AI or API. Is
Yeah,
it what are the actions that you imagine that it would be able to do? Is this like I have an element, please embed it for me, or is it I have an embedding, please find all of the elements that are closest to it?
you could do all that. The first thing we're going to do, um, let me go back to this other one. The core AI Commons, you'll be able to ship a model or ship a containerized workflow and do 80% of what you want to do. The role of the embeddings is twofold. One, there are a lot of RAG and agentic services that need embeddings as first-class objects, so you'll have that. So you got that. Two, we have a number of papers now. Well, I got criticized for saying a number when the number's less than five. I was told if the number's less than five, say the number or don't come back to my office. So we have three papers, not a number, but we have three papers for use cases which show that if you have high quality data and you have good embeddings, foundation model or any of the standard embeddings, you can often build a small to mid-scale model, even a machine learning model, and not even an AI model that performs as well as some of these much bigger uh, frontier models because they don't have the same data. So one of the really important roles of the embedding service is the embedding service can be applied fairly simply to all the data in your commons. And then people could build custom models in small workspaces or a small number of GPUs. So it allows you to build pretty performant models that are small to mid scales that perform well. But you do that because you have these powerful embedding services that are just there over all the data. Once you have them, you could do all the other things you just mentioned too. All right. We should do is Claire and Steve, if Stephen is still there. Um, yeah, so Alan, over some of our comments, we've put MCP servers. So what will come in the Gen3 AI comments is just the ability to put MCP and agentic in there. It's not a big lift. I'm a little worried about security, but we are doing that now in some of our applications. If you are actively, Alan, doing MCP and want to help us inform the requirements as we put that into our agentic interfaces. That's one of the core things we're doing. Just let us know. Anyone from the community who has opinions about how we put the agentic into the AI Commons, please let us know. Otherwise, we're just built on our experience. Michael, do we have enough information to write something we could share with the community to reflect what we learned on this call?
Specifically about the AI discussion or
No, let's not try to capture the AI because we have a whole process and we could have a community forum on that. Did we learn enough that I don't think we heard any changes to the roadmap, did we? Or did we?
not yet, I guess. I don't know if we've heard the last word yet, but there hasn't been yeah, any significant changes.
No, I would agree, and I think I guess this is the opportunity, right? If people
Yeah.
think there's things missing, to point that out, and I think also probably we can open to any other questions related to fairly well anything at this point.
We can. Let me make one suggestion. The easiest way to change the roadmap is just to write a letter, say, Dear Michael, I like your roadmap, but I want to add this. I have 3 people on my team which will help you. All we need is a little bit of liaison and support from the Gen3 support team, and Michael will say yes. So if you that's the easiest way. There are other ways to change the roadmap, but you can always write what we call a Dear Michael letter in Gen3, and I'll volunteer some people to add something to the roadmap, and we'll help just as everyone did for CSOCs, but maybe we won't have 3 implementations next time, just 1 implementation. Michael, back to you.
No, yeah, thanks, everybody. Claire, was there any more? Did you want to, I guess we were going to turn it over to the community to see if, yeah, folks, type, unmute, raise your hand. We'd like to hear from you. It's not, that you can't continue to reach out and give feedback, but this is a great opportunity to do so. One kind of related question is, for this year, we're looking about whether we should have additional working groups. So for the CSOC working group, this is a group of those Gen3 operators that have multiple systems that we kind of wanted to get together to work on some new systems or new features. But there's plenty of other Gen3 features that could have a working group around them. Maybe something you saw on this roadmap. So if folks are really interested in one of those items you saw and think it might make a good working group, please let us know either now or offline. Okay. Well, not hearing any more. So I guess we'll kind of wrap up today. Thanks, Claire and the steering committee for helping. Thanks, community, for listening to these updates. I hope they were interesting. Please reach out if you have feedback that you weren't able to get to today. We haven't settled on the topic for the next community roadmap, which is in about 2 months, but hopefully we'll send out something shortly on what that will be. But please reach out on Slack and hopefully we'll see you all soon. Take care.
Thank you, everyone. Cheers.
Thanks, everybody.
Yeah.